All right, now that you guys have learned how to make a scatter plot, this is a section that has you looking at scatter plots that are already made and seeing if you can decide what a relationship is between the X and the Y coordinate, okay? So in this one, it starts with an example about kids that are conducting an experiment and they want to see if there's a relationship between the wingspan of a paper airplane and the distance that the paper airplane will fly. So the wingspan is basically how long it is from tip to tip of each wing. And they're curious, if they change the wingspan, will it change how far their airplane will fly? So it says, how far did the paper airplane with a wingspan of 3 inches fly? So you have to go over to your data shown on the scatter plot, and you see it's got wingspan along the x-axis, and it's got the distance of flight for the paper airplane in feet on the y-axis. So they want to know if the paper airplane had a wingspan of 3 inches, that would be here between the 2 and the 4, then what would the y coordinate be? Where is that dot? Here's the dot. So what's the y coordinate? It's 15. So what does that mean? It went 15 feet. So the point with the x coordinate of 3 has a y coordinate of 15. And based on the data that these kids collected in their class, we know that a paper airplane with a wingspan of 3 inches flew 15 feet, at least for their experiment that day. Okay? And you notice when you look at their scatter plot, you start to see that pattern, kind of like the one we saw last time with how long you were at the mall versus how much money you spent at the mall. And we noticed that here again, as the wingspan increases, then you notice your distance that the airplane flies is also increasing. The dots are getting higher and higher, okay? So down here, it's just an example of ways that you can make generalizations about what you just saw. And so this is an example. If it looks like the dots are getting higher and higher, well, a fancier mathlish way of saying that is as the x value increases, the y value is also increasing. And remember, this is your x and this is your y, okay? And then if you notice that all of your dots at first, they seem to be higher. And then as you move along the x-axis, you notice that the y value is decreasing. The dots are getting lower and lower and lower. Then you're noticing a pattern. It's just a different kind of pattern than what you noticed before. And the way that you would say that with your mathlish would be, as the x value increases, the y value is decreasing, which makes sense when you think about it. And then sometimes, like we've said before, you're going to notice when you look at a scatter plot, there's really no pattern at all. All you see is kind of crazy randomness. And it's okay to say there's no relationship between the x and the y values. Sometimes it's not there. You think there's going to be a relationship, but when you actually build your scatter plot, you see there's no relationship. Okay? So then the question says, what happens to the distance of those paper airplanes and how far they can fly as the wingspan increases? So when we looked up here, as the wingspan increased, so you're moving along that x-axis, what happens to the distance? Well, the dots keep getting higher and higher as you move out here to bigger and bigger wingspans, right? So we see that it's starting to just kind of move this direction. The dots are starting to get higher and higher, so they increase, right? So what happens to the distance paper airplanes fly as the wingspan increases? The distance is also increasing. The distance of flight, I'll be more specific. The distance that the paper airplane can fly also increases. So the longer the wingspan, the further it will fly. So the kind of relationship here matches this one. As the X value increases, the wingspan, so does the Y value. In this case, the distance of flight. They're both increasing. All right. Hope that helps.